Hello and welcome to, I believe this is going to be part 11 of my skywatching series project videos. If you've watched some of my previous time-lapse videos, you'll be able to see as the sun comes up, the shadows that it casts on the trees and along the house like this. There's also another camera that I plan to show. This one, I've got to make some time-lapse videos on this one, but the shadow cast on the house here is much more pronounced and through the trees as well. When I was watching the time-lapse videos, I was thinking of trying to implement something in a slightly different way, and I wanted to tie that into a video scene rendering tool called povray. I was thinking of using the output from this to feed povray so that povray could position the sun and the stars and all of the other celestial objects, creating the appropriate shadows if I create some objects in between. Initially, I decided I was going to do something basic. I took my application and modified it so that I can instruct it to save a copy of the data that it produces that can be used directly in povray. And this is a sample of the result. Each scene that is rendered has a declaration of the latitude, the longitude, year, month, day, hour, minute, seconds, and the time zone adjustment. This is in hours and fractions of an hour. I also include the Unix timestamp. In this case, this is something else that I've added. It's the sun's declination from the point that the sun passes the zenith, kind of like the 0-hour angle. Altitude is minus 63 degrees for this location, and the azimuth is 336 degrees. I've also got the same thing for the moon. So the moon has an altitude of 22 degrees and an azimuth of 266. The individual stars are like this. I wanted to include the star's name over here, but I could not figure out how to get this thing to provide mixed arrays. So what I've done is I've created a separate array down at the bottom for the star itself. The first element in this array is Akamar, which corresponds to the first element of this array. Here's my script that I wrote, and I plan on making this script available. I'm going to put it on my G drive, and I'll put the link in the description so you'll be able to grab this. And I've got a number of these rendered scene files. I don't know what to call these, but I have a number of those, and I'm going to talk about those in just a minute as well. But I'm going to make several locations available so that you can download everything and play with it all you want. These are some initial default values. Then I have a separate file that you can use to override these default values. So if you want to create a script that goes and generates a scene, you can change this file and then rerun povray, and it will use these values overriding these and change the scene that way. And then after that, you can assemble all of the images together into an animation. And then finally, rather than switching back and forth between all of these windows in this demonstration, I've got a temporary override. And when I make this available, these will just be commented out like this. When I change these values here, just think that I'm changing them in this external file instead. Then I won't have to worry about that external file and switch back and forth to show what's going on. So the next thing is based on the scene in question. I zero pad to 6 decimal places and derive the file name for a particular scene in question, and then I instruct povray to include that particular file. So if I say I want 600, or in this case if I want scene 0, I just do that, and now it loads a different scene. And to give you an idea that these are different, Here's the difference between scene 0 and scene 1. You can see that the latitude, longitude, year, month, day, and hour are the same, but the minutes are different, 27:26 and 28:26. So each of these are 1 minute apart. And you can also see this is azimuth 336.57. This is azimuth 337.07. Once all the data has been loaded, then I have a macro. And the macro right now has a couple of parameters that have been a bit of a failed experiment. I might make another video later to describe that one. But the main ones are these. Radius is how far all of the stars are away from the observer. And you'll see that all of the stars are going to be at the same distance, but the sun and the moon are slightly closer than that. With arrows, you'll see in a minute, whenever I turn that feature on, it'll draw an arrow as well that points to that star. This part is irrelevant at this point. This is the main part. 1, 2, and 3 calculate the points in space for the arrow. 4 calculates the point in space for the object itself. I create a sphere object, and if needed, I also render the components for the arrow. This macro will define whether or not I call the other macro, specifically if the altitude is above a given altitude, and I'll show that in a minute. Then at this point, I go and I calculate the direction of the camera. I go and place the light source where the sun is, and then I go and I draw the object for the sun, whether or not I want to draw the ground that you see here. The next point is to draw the moon, and then finally I iterate through all of the individual stars and I render each one. And here you can see the shell radius is 8 and the stars are a shell radius of 8.5. So the first thing I've shown is the scene in question. So I can say I want scene 1, and it goes and renders a slightly different view. Pay attention to this star. I'm going to switch back to scene 0. It's not quite in the same spot anymore. Pay attention to these two. I'm going to switch back to scene 1 for a second. Pay attention to these stars and these 3 stars here. So if I pan up a little bit to, let's say, 25 degrees, those 3 stars are still over here, and these other stars are down over here. And if I go up 30 degrees, you can see that all I'm doing is I'm looking up like this here. I can change the azimuth of the camera. So if I rotate, so right now I'm facing due south. If I rotate in this direction slightly, these stars should shift over here. Gonna go back to 180. I can also rotate the camera on its axis like this. If I go 20 degrees, for example, it should rotate in this direction somehow, maybe. So pay attention to these stars here. You can see that the ground is now over here at an angle. And I added this because I want to make an animation that shows what it would look like if the camera was attached to an equatorial mount. And as the equatorial mount tracks the sun, for example, or a particular star, that the entire scenery stays exactly where it is and that the ground moves up in this direction like this, at least from where one would be at 45 degrees. So I tilted the camera back down just slightly so that I could turn this feature off. If I don't draw the ground, then you won't see this gray thing, and you don't see the stars below ground level because I have a minimum altitude of -1, which will hide the stars that you can't see, and that would be useful in another animation that I'm going to show in just a minute. So I'm going to make this greater than -99 degrees, and that will essentially show all of the stars. The next remote view is to back the camera up from the position you are currently at for the final set of features that I wanted to show. When I back up, you'll see that these stars appear to be slightly smaller because these are at a distance of 9 units and I'm backing up 6 units. So these stars will appear to be slightly smaller. Here's those same stars, just zoomed out slightly. So now I can show the last features, which are to draw arrows pointing to the objects. Now in my code, I have just a sample of them because you'll see it'll look very busy if I show all the arrows. So by default, I have a certain number of sample objects that I want to have the arrows pointing to, but I can show the arrows for all of the objects later. So keep that in mind. So I have the yellow arrow is for the sun, the blue arrow is for the moon, and then I have a sample of 5 stars: Polaris, Cocab, Polaris Australis, Altair, which was the first star that I saw captured from my security camera, and it might be this one. And then finally, Betelgeuse from the Orion constellation. And last but not least, I can show all of the arrows, and I have a total of 336 stars. The minimum altitude was meant to work mainly for this mode as well. You can choose to only display the stars that you can see visible. So what it does is it only renders half of that. And as you animate and as this rotates, some of these will disappear and other ones that are just below the horizon, when they show up above the horizon, those arrows will show up. So if I change the scene to, let's say, 10, you can see that the configuration of these arrows changed slightly. That's basically my script in a nutshell. I haven't worked out exactly all of the things that I wanted to add. There is apparently a way to render some text, but I need I guess a TrueType font file, and I haven't had enough time yet to go looking for one on my computer and setting it up. But I wanted to have a box up here that had the latitude, longitude, the time zone, direction of the camera in a very similar way that I have here. As I said earlier, I plan on making all of these files available so you'll be able to get a copy of them and play with them. And hopefully you'll be able to come up with some very interesting animation sequences from the result. And I can also export data for other days as well. The main thing is that I wanted to create a set of time-lapse videos based on nothing more than these data points that would show the sun casting a shadow under the soffit of the house like this and cast by the branches of the tree, so that I could run the two side by side, show the pictures that the camera took over here, and then show what povray rendered over here based on the same time of day. At this point, I'm going to show a series of animations that I rendered. Hopefully you're going to like them. As always, do the YouTube stuff, do the like, comment, share, all of that good stuff. Thanks for watching, and I will see you again in another video soon enough. So bye for now.